which requires more work. Walking up or down the stairs. And here's the thing, there is a huge misconception about that, right? There's a misconception when people say work. Guess what? They require exactly the same amount of work, which is crazy when you think about that. Because, I mean, as everybody would say here, we all know, right? Everybody would clearly say, well, it's harder to go up the stairs. I'm doing more work as I go up the stairs. So what I want to do here is that I want to analyze going up and down the stairs. So let's go do that. So what I need to do here is that I need to set up two situations. And the situations that I want to set up is walking up the stairs and walking down the stairs. Okay, so here we go. So let's talk about walking down. Oh no, how about walking up the stairs is the first one. This is the first one that we want to look at here. So what I need here is that I need to, of course, need to set up stairs. So let's set up stairs. So here's the ground floor. What I'm going to do here is that I'm now going to have a set of stairs. Okay, here's my stairs. Now, when I'm thinking about these stairs here, I'm going to label these stairs. But what I'm going to imagine here is that somebody has to walk up the stairs. Okay, so that means somebody has to put their foot on the stair. And as a consequence, the other foot has to be lifted up. But this is what has to happen as you go up the stairs. So what I'm going to do here is that I'll label the stairs here. I'll label this stair 1, 2, 3. Now, let's look at this thing here now. So what we're going to do here is that let's start by, let's start by thinking about this. What are the forces that make you go up the stairs? That's an important question. So I'll ask here, what force makes you go up the stairs? And I know the funny thing here is that people are going to say, well, it's my leg. Of course, it's your leg. And the answer is, that is not correct. So what we want to do here is we want to focus on the foot here. So what's really, really important here is that because remember, this leg is up in the air. So that means that that foot that's on the stair, what we then say here is that this is the full weight is on one stair. So then here we go. So if I start to draw this, that means here is that this must be the force of what? of you pushing down. So this is the force of the foot on stair. So according to Newton's second law, or third law, excuse me, there has to be a what? An equal and opposite force. So that force is the stair on foot. So what makes you go up the stairs? It's the stair, right? You got to push down so that the stair could push you up. So what we're saying here is that from Newton's third law, we push down with our foot. So the stairs pushes us up. That's what Newton's third law says. So then that means here the force of the foot must be the force of your weight. So this is the weight because it's all, since the other foot is in the air, all of your weight is on that one foot. So if that's the case here, then Newton's third law says that this has to be the force of the stairs. Okay? Okay, so that's what we have right there. So now we know what the force is. Now let's go down the stairs here. So now we need to be walking down the stairs. So I need to do something similar. Right, so I need to set up the stairs. So let's set up my stairs. So when I look at my stairs, what you're seeing here is that I got to do what? Well, I got to come down the stairs. So here I go. So what I'm going to do here is that, of course, my stairs now are labeled 1, 2, 3. And then as I come down the stairs, what actually happens here? So what happens here, as I come down the stairs, again, your foot is fully on that one stair while your other foot is in the air. So again, this is in the air. And then this guy right here, what we're seeing here is that there's a full weight on one stair. So again, if I analyze it exactly the same way as I did before, we could see here that there is the foot of the force pushing down, and as a consequence, it's the stairs that pushes us up here. So as I come down, these forces are equal again. So these forces are exactly the same going up or down the stairs. So again, when I look at the weight that you put on that one stair, it's the force of the stairs that has to be the same. So now let's look at the work. So what this means here, it means the following thing. So if one goes up and down the same number of stairs, then that means that the distance is the same for both situations. So in this case, if I go up 3 stairs, that's my distance. If I go down 3 stairs, that's my distance again. And those two distances are the same. So what you're finding here is that then the work going up, which will be the force going up, and then we have the distance versus the work coming down. Well, that has to be the force of down has to be exactly the same. And what you're seeing here is that these quantities are exactly the same because why? The forces are the same. And now the distances are the same. And as a consequence, we then say that the work going up must equal the work going down. Right? What's the misconception here? The misconception says, I work harder going up the stairs than going down the stairs. And what I'm saying is that this is what? This is a misconception. That is not correct. So if that's the case, there has to be a problem with our language. So if so, that means here is that our language in everyday situations must be incorrect. And it is incorrect. And what we find here is that people are talking about power, not work. So your power output going up the stairs is higher than your power output coming down the stairs. That's what we should really be saying, but that's not everyday language.